16. First, find the reflex angle BAQ. Over here, I've done some working already. So if you notice, first, interior angle of hexagon, okay, n minus 2 times 180 degrees, sum of interior angles, divided by 6 sides. So each interior angle of the hexagon is 120 degrees, which I've already labeled over here. Now, want the reflex angle BAQ. Okay, notice reflex angle BAQ is this outer angle here, okay, not this inner one. This inner angle down here, okay, a smaller one, the obtuse, is actually an obtuse angle, but what they're asking for is the reflex angle. A reflex angle is between larger than 180 degrees and smaller than 360, so it's actually this angle over here. So what I've done is 120 plus 90 degrees. Why 90? Because AFPQ is a square, so 120 plus 90 degrees gives me 210 degrees. Next one, we have angle AQR. Okay, first, we know that BCSR is congruent to AFPQ. So this side and this side, they are actually the same. Alright, so therefore, if you notice now, ABQR, these two sides are equal. Okay, it forms a trapezium. So for this trapezium, AB is actually parallel to QR, like this. So if I want to find AQR, first I find obtuse angle BAQ. So for A part 2, I'll say obtuse angle BAQ is 360 minus reflex angle 210. It is equals to 150 degrees. I shall now label them as 150 degrees. So two parallel lines, we can employ the interior angles. So I say that angle AQR is equals to 180 degrees minus 150 degrees is equals to 30 degrees. And this is because of interior angles. AB is parallel to QR. Okay, so AQR is 30 degrees. Part B, show that PAR is a straight line. So in order for me to show that this is a straight line, the first thing I have to do, okay, down here, if in order for this to be a straight line, over here, this angle PAF, FAB and BAR should actually equate to 180 degrees. So first and foremost, if you notice, alright, down here, this triangle here, okay, BAR is actually an isosceles triangle. So first I'll try to find angle, okay, part B, BAR. Angle BAR is simply equals to 180 degrees minus 150 degrees divided by 2. Why 150? Okay, this is 150. This is also 150. Because these two sides are equal, it's symmetrical. So it's 150 degrees here as well. So BAR is an isosceles triangle. I take 180 minus 150 divided by 2. I have angle BAR is 15 degrees. And my reasoning is isosceles triangle BAR. So this is 15 degrees. Let me label this as 15 degrees. Now, FAP, okay, is a square. So if I want to find angle FAP, okay, I take 180 degrees. Angle FAP or triangle FAP is an isosceles triangle as well. So I take 180 minus 90 divided by 2 is equals to 45 degrees. And I say that this is isosceles triangle FAP. And then I label this as 45 degrees. So now, to show the angle PAR is a straight line, okay, I say that angle PAR is equals to 45 degrees, down here 45, plus 120 degrees from here, then plus another 15 degrees from here is equals to 180 degrees. So therefore, okay, since angles on straight line add up to 180 degrees, I can conclude that PAR is actually a straight line. over here just like that. That is part B. Okay, now for part C, they say that additional squares and hexagons are added alternatively to diagram 1 to form a regular polygon. ABRQ. Regular polygon, that means all the sides are actually the same. Okay, so they are equal. So what we can do first will be this. I know that the interior angle of each polygon, alright, the interior angle, just now we have found, each interior angle is a 150 degrees, like this. So, if the interior angle is 150 degrees, alright, I can now find that the exterior angle of polygon, let me draw the exterior angle for you over here, this 150, if I draw out the line over here, this angle here is 30 degrees. So first I'll say that exterior angle of polygon is equals to 180 minus 150 is equals to 30 degrees. So simply once you have the exterior angle of a polygon, my number of sides of the polygon is equals to 360 divided by 30 is equals to, how much do we get here? Is 12 sides. So therefore this polygon here, if it is drawn completely, will consist of 12 sides. So 12 sides, notice that one side will be a square, one side is a hexagon, one side is square, one side is hexagon. So we work in terms of pairs. There will be 12 sides, but there should be 12 divided by each pair is made up of one square, one hexagon. So we take 12 divided by 2, this 2 represents one pair each, is equals to 6 pairs of hexagons and squares. Okay, so one hexagon square, one hexagon square, one hexagon square. So there's 6 pairs. So far, we have already drawn 2 squares down here. Question says, how many more number of squares added? Okay, so how many squares? There are already 2 squares there. So there should be 6 squares. Alright, so I take 6 squares, minus away the 2 existing squares. I will have 4 additional squares that need to be added in order to complete the polygon shown down here. And that will conclude 16C, but I will just show you the working for 16C over here. Just give me one moment. Okay, you may pause your video if you want to see. This is 16A1, 16A2, 16B. Okay, and the answer for 16C over here, just pause it for a while so that you can pause your video and make any corrections that you need to do. And that concludes question 16.